Okay, so this should be the shortest video ever because there's only two problems, right? Problem A is that we have this alternating series, and the alternating series is also has a fancy name. It's called the alternating harmonic series, and the reason why the harmonic series is just the 1 over n series, and this is alternating because it's going from positive to negative, negative, back and forth. So the question that we have in this problem is we're asking how far off, like what is the error going to be if we use the first 4 terms to approximate this series. So if we wanted to, again, we could do this. You're not asked to do this, right? But we could use the first 2. We could say, hey, the first one is 1. Then it's going to be, is it 1 or is it negative 1? The first one's, it's 1, right? And then it's going to be negative 1/2, then plus 1/3. And that's the series, right? And the question that we're being asked is, how far off? If we use this, if we say, hey, we're going to use this to approximate this, right? And we're going to use this, just these 4. We're going to use S of 4. How far off are we? And we're going to be this far off, right? We're going to say, well, we don't know how far off we're going to be. Let me change that. We don't know how far off we're going to be. But we do know that, because we don't know this, right? We don't know how far off we're going to be, but we do know that it's less than this. So we know that our error, this is our error, the error that we're going to have if we use the first 4 terms to approximate this infinite series is going to be less than 1/5 or 0.2. So the answer is the error is going to be less than 0.2. So if you add 1 minus 1/2 plus 1/3 minus 1/4, you get some number. That number is effectively going to be off. And how far off is it going to be? Well, we don't know, but it's going to be off by some number that's less than 0.2. If you want less of an error, add up some more. Okay, next one. Again, we're alternating. Nice alternating series here, okay? And we're being asked the same question. If you added up the first 4, now adding up the first 4 for this one's a little bit less fun, I guess. Just for those that would like me to do it, I'll do it. 0.01 plus, sorry, it's minus now, right? Just so you could see. I mean, you don't need to do this. This is absolutely unnecessary. And wow, this gets pretty, wow. I think I'm going to probably wind up making a mistake with all my zeros. I'm glad this is my last one. Okay, I think that's what it's going to be, right? But you have no need to do this. This is absolutely irrelevant, right? You don't need to do this. But the question is, if we use this to approximate the overall infinite series, how far off it will be? Well, this is getting pretty small pretty fast, right? I mean, my feeling is that we're getting pretty close pretty quickly. I mean, look how small this is already. So the amount that we're off is going to be less than the 5th term. What's the 5th term? Well, the 5th term is going to be the absolute value of the 5th term. So we don't need to worry about the negative 1 part. It's going to be 0.01 to the 5th over 5. So, I mean, that's the error. That's the answer, right? I mean, nobody would really want to see it that way. I guess the better way to write it would be 1 over 5 times 10 to the 10th, I guess. I guess that's a better way to write it. I mean, even that's not nice. Probably would go to scientific notation. What would that be? That'd be like 0.2 times 10 to the negative 10, which is what? 2 times 10 to the negative 11. So maybe that's another way to write it, right? I mean, you shouldn't leave it this way. That's pretty ugly. Decimals in a fraction is bad. So I would say leave it like this or leave it like that. All right. Quickest video ever. Enjoy, folks.